For centuries, time was measured as a continuous, fluid motion. We tracked the slow crawl of shadows across a sundial or the steady pouring of water from a vessel. Time simply flowed. That changed in the 13th century. Within European monasteries, the need for strict prayer schedules led to the installation of weight-driven mechanical clocks, massive iron frameworks that abandoned water for the pull of gravity. To make these clocks work, inventors needed a way to stop the descending weights from simply plummeting to the floor. They developed the verge escapement, the first mechanism capable of regulating the release of energy in a gear train. A weighted crossbar swings back and forth. As it oscillates, two metal pallets alternately catch and release the teeth of a crown-shaped wheel. Each time a pallet locks, it forces the gear train to halt and recoil before escaping. The tick you hear is the literal sound of these metal components colliding. It is the acoustic shock of a gear being physically arrested thousands of times a day. This invention transformed time. It was no longer a liquid, but distinct mechanical beats we could count and categorize. By the 15th century, the goal shifted toward portability. To make clocks small enough to carry, watchmakers replaced the massive falling weights with coiled mainsprings. This introduced a new physics problem, torque decay. A tightly wound spring pushes with great force, but that force weakens as the spring uncoils, causing the watch to lose minutes every hour. The solution was the fusee, a conical, spiral-grooved pulley that acts as a mechanical transmission. Its shape is a hyperboloid, calculated to perfectly balance the changing tension of the spring. The mainspring barrel is connected to this cone by a steel chain. This chain is composed of hundreds of individual links, each microscopic in scale, providing the bridge between the power source and the gears. When the spring is fully wound and its pull is strongest, the chain is wrapped around the narrow tip of the cone. As the spring's power fades, the chain unwinds toward the wider base. This chart tracks the result. The dropping line is the spring's tension, while the rising line is the mechanical leverage provided by the cone's increasing radius. They cancel each other out, resulting in a constant, flat delivery of power to the watch. The fusee allowed us to create a closed mechanical system that effectively negates the natural decay of physical energy. While the fusee stabilized the power, the accuracy still depended on the regulator. In 1656, Christian Huygens applied the physics of the swinging pendulum to the clock. But a standard pendulum has a flaw. Wide swings take longer to complete than narrow ones. If the weight swings too far, the clock slows down, a phenomenon known as circular error. Huygens discovered that if the pendulum bob followed a cycloid curve rather than a circle, it would remain perfectly isochronous. He achieved this by placing curved metal cheeks at the top of the pendulum string, which subtly shortened the swing's radius as the weight moves outward. This mathematical correction was a massive leap for precision. Timekeeping accuracy jumped from a variance of several minutes a day to just a few seconds. By applying an abstract geometric curve to a physical machine, we successfully aligned our mechanical devices with the predictable laws of physics. The peak of these mechanical innovations arrived in the 18th century workshop of Abraham Louis Breguet, the watchmaker to the French royal court. In 1783, Breguet received an extraordinary order for Queen Marie Antoinette. The commission demanded a watch that included every known complication, from perpetual calendars to thermometers, with no limits on budget or time. The watch is a masterwork of packaging. Within a single chassis, Breguet managed to house a fusee, an escapement, and a series of astronomical calendars that track the recurring cycles of the heavens. The watch took 44 years to finish. By the time it was completed in 1827, both Breguet and Marie Antoinette were dead, and the monarchy had been dismantled by the French Revolution. Known as the Breguet No. 160, it remained the most complicated timepiece ever constructed for over a century. These machines represent a specific ambition in engineering, the attempt to replicate the recurring cycles of our solar system within a device small enough to carry in a pocket.